Okay, once again, today is part 2 of what we started with simplifying algebraic expressions. So our objective, I can simplify and evaluate algebraic expressions using order of operations. Read together, 1, 2, 3. I can simplify and evaluate algebraic expressions using order of operations. So if you notice, last night's homework was pretty simple. Just like some of the last problems they had, just multi-steps, and it had you thinking a little bit more outside the box, right? And some of them were like guess and check and so on and so forth. Yeah. So you don't need a Fourier model because yesterday I already covered what algebraic expressions were. And remember I introduced the expressions using opera and reggae, remember that? Yeah. Numerical and algebraic. From there we went into the algebraic expressions, definition, examples, non-examples, and then I gave you guys steps. 4 easy steps. Substitute the values of the variables, use the order of operations, use cat properties, and simplify. Then we did a quick overview of order of operations, and then we did a couple of these, right? Okay, and for homework, they gave you something like this to simplify, and they also gave you some that looked like this, where you wrote 2b plus 4s plus 7d, and they gave you values for each variable, such as 10 equals b, 6 equals s, and 5 equals d. And what did we do? We just substitute values. So this is 2 times 10 plus 4 times 6 plus 7 times 5, and that became 20 plus 24 plus 35, which is 79 buckaroonies, because we're talking about money collected for gift wrapping. Are we there so far? All right, so that was for homework last night. Today I want to clarify some terms. Now, why am I going to clarify some terms? Because I want you to make sure, as we continue, that you're clear in regards to what I'm saying. Because I don't want to be talking over here with all these terms and you guys just wait for the process. No, I want you to understand what you're looking at. Terms. What are terms? Terms of an expression. If I was to give you this expression, 4x minus 3x plus 2. Check this out. This expression can be broken down into parts. How do we know that? By looking for addition or subtraction. Do you see any addition or subtraction? Yes. Here's one and here's another. And that breaks the expression into 3 terms. Are we there so far? Now, when we classified polynomials, we said if there's an expression of 3 terms, then it's called a trinomial. And that's the purpose of knowing the number of terms. So far, so good? So, from there, by looking at the terms, that's the name of each part of this expression, we need to look at which ones have the exact same variable with the exact same exponent so that we know that those are like terms. That's what they mean, like terms. So, what do you see that have exactly the same variable with the exponents? The 4x and the 3x. Those are like terms. Are we there so far? However, the 2 does not have a variable. That has a specific name. That's called a constant. And why is that called a constant? I said if we were to substitute values into x, such as x equals 5, we substitute that in there and there. This becomes 4 times 5 minus 3 times 5 plus 2. I simplified. This is 20 minus 15 plus 2. But look at every step. Which one did not change? The 2. It remains constant. That's why that one's called a constant, because it doesn't change. Does that make sense? Yeah, right? So now that we got those terms covered, okay, so once again, like terms, the different parts of the expressions, and constant. Coefficients. What are coefficients? Coefficients are the numbers that multiply the variable. So if I was to give you this, look up, how many terms do you see? 2. Are they like terms? No. But what is the coefficient of the first term? 1. It's the number multiplying the variable. And the coefficient of the second? 3. The number multiplying the variable. These are called coefficients. Are we there so far? Okay. So copy this one now, please. and we'll do this one together. It says, example 3, simplify the expression by combining like terms. First of all, let's identify how many terms or how many parts does this have. First of all, do we have addition or subtraction? Yes, subtraction right here. So that means it breaks the expression into two parts, this one and that one. That's where it's two terms. What is it called if it has two terms? It's a binomial. Binomial. I'm going to keep doing this so we can keep practicing the name of them. And I still haven't practiced with a degree. Right now I'm practicing by terms. Okay? So two terms. Are they alike? Yes. If they're alike, then we just write the whatever they have alike, and we're going to focus on the coefficients. The coefficient for this one is 72. The coefficient for this one is negative 25. Why did I include the negative? Because I said from now on, whenever you see a negative, you circle it together with that number, and it's going to become a negative. Therefore, what is 72 and negative 25? 47, and we're done. That's how we combine like terms. So far so good? Let's do another one. Example 4. Copy this, 3b. It says, example 3b, we have 3/4 x to the 4th plus 1x to the 4th. So once again, how many terms do you see? Everyone. 2. What is the name of this one? Binomial. Okay, so far so good? So, are they like terms? Yes, so we write whatever they have alike. There it is, that's what they have alike. And we're going to focus on the coefficients. What's the coefficient of this one? 3/4. What is the coefficient of this one? So what is 1 plus 3/4? 1 and 3/4. So far so good? Okay, let's do another one. Example 3c. Let's see if you see what I see. Example 3c. 0.5m plus 2.5m. Go. 20 seconds. Alright, a slider. Okay, who saw the slider on this one? Okay, so some of you right away your noodle started adding the decimals, but no, they don't have like terms because this one has an M and this one has an N. It stays the same. Everybody see that? Yes. Of course you leave the plus sign because it's an expression. Now, this is the way I look at expression. It's kind of like your language arts teacher looks at sentences. Sentences have a period at the end of each sentence, or paragraphs per se, right? At the end of each sentence in a paragraph, there's a period. That's what a plus and the minus are, and an expression. Imagine this is a paragraph. How many sentences do you see? 2. Here's 1, and here's another. It's an invisible plus right there. Anyways, let's continue. Copy this one. Example 3, low cap A, B, and C. You got 1 minute. And for A, it says 16p plus 84p. For B is negative 20t minus 8.5t. For C, 3m squared plus m cubed minus m squared. Go. Okay, let's see. For A, how many terms? 2. What is the name of this one? Binomial. Do they have like terms? Yes. So this is P. 16 plus 84, that's 100. For B, are they like terms? Yes. How many terms do they have? 2. What's the name of this? Binomial. So therefore this is T. Coefficients are negative 20 and negative 8.5, so that's negative 28.5t. C, how many terms on this one? 3. This is a trinomial. Therefore, do we have any like terms? Yes, this one and this one. So watch. I'm going to write 3m squared minus m squared, and at the end plus m cubed, so that you can see how these are alike. What did I just do? What is that property? Commutative property of addition. From there, if I group these, m squared, combine the coefficients. This is 3 and negative 1, that is 2. Bring down the m cubed, and I'm done. Hands if you got all three of them. Okay, pretty good. So now, just to clarify, yes?
Wouldn't you put m in power first?
So, they're saying, can we write this in standard form? Sure, let's write this m cubed plus 2m squared. Thank you for the observation. Yes, and for right now, I was just showing the combining like terms, but yeah, I've been asking you guys to write it in standard form. Thank you. So now, the other clarification, everybody look up. This is a common mistake that I keep seeing and that I saw on some of the parties. Watch. This one, 16p plus 84p. Some of you did this, 100p squared. Think about it. What is the common mistake that we saw there? What do you see happened? Yeah.
Oh, well, when you add, you just leave the exponents alone. So it's only when you multiply you add the exponents.
So make sure you make a mental note for yourself for these. Remember, the only time we mess around with the exponents is when we are multiplying. Are we multiplying here?
Yeah.
No, it's addition. So therefore, we don't do anything to the exponents. That's why we don't do this. Everybody with me? Okay, just clarification. Okay, let's move on. Copy this next one down, please. Example 4 reads, use properties and operations to show that 14x plus 4 times 2 plus x, close parentheses, simplifies to 18x plus 8. So now I'm going to show you a process on how to simplify these and show that this is this. Okay? So, once you copy this, make this table, please. Copy this table. Has a column here, and it's titled its statements, and the column for this one, it's titled reasons or properties. And then I'm labeling the steps. Let me move this out of the way. There it is. Okay. It's got steps, and for step 1, I write 14x plus 4 times 2 plus x. Copy that. So check this out. So they're saying use properties and operations to show that this simplifies to this. So first of all, look up please. Where did I get this from? Tell your neighbor, where did I get this from? Where did he get it from? Everyone? From the problem. Whenever we start, look up please, whenever we start this process and we write whatever's in the problem, we're going to write as a reason, we're going to write given. So write that for the reason once we write that. So, now that we're getting started, what would be our first step in order to simplify this expression? Look at it. Yes, Andrea, what would be the first thing you would do? Get rid of parentheses. But they're saying it has to be a reason with a property. So what is the property that I use in order to get rid of that parentheses? Andrea? What is it? Distributive property. That is correct. So watch. You write for step 2 the reason, distributive property, and we show with arrows here that the 4 is going to multiply times the 2 and the 4 times the x, and we write it out. 14x plus 4 times 2 plus 4 times x. Here we're showing the step. Distributive property. Did everybody see that? And now that we show the step, can we multiply here? Yeah, so we write multiply. So what is 4 times 2? 8, and 4 times x, 4x, so we write that right there. So look at them. For step 4, what would we need to do next? Think about it. What do we do next? Talk it over with your neighbor. What do we do next? Okay, let's see. Oliver, what would we do? Identify like terms, okay, and you saw which ones they were. 14x and 4x. So to get them together, that is correct, identify. To get them together, what property is that? Commutative property of addition. Write that down. And we're going to identify that 14x is together with 4x plus 8. Now that we identify them, can we combine them, the 14x and the 4x? Yeah, right? And remember, what do? I put a parentheses, don't I? That's the associative property of addition. So I write it as parentheses 14x plus 4x plus 8. And at the end, combine like terms. So what is 14x plus 4x? 18x plus 8. Now, throughout the year, we're going to do a process that I introduce all of my students to that are called window notes. And why do they call them window notes? Because we get a paper, watch, and we fold it first vegan sandwich style, and then from there we fold it again, vegan sandwich. When we open it, it looks like a window with 4 partitions. Does that make sense? But check this out. This will be one window. This would be another window, and we have 2 more things to do. But why are we doing this? Check this out. This, in geometry, is called 2-column proofs. So when we practice this, I'm trying to get you guys ready for geo. Everybody with me? So, any questions on the process, how to use this? No, Mr. Q. All right, then copy this next one, please. Example 4B. 4B. It says, use properties and operations to show that 6 times x minus 4 plus 9 simplifies to 6x minus 15. And make your table, your 2-column table. There it is. So tell your neighbor the reason for the first step. So yes, first step is given, because it's in the problem. So then what do we do after that? Tell your neighbor, please. Step 2. Damn. So the first step is given. I heard second step, distributed property. So you have something like this, 6 times x minus 6 times 4 plus 9. Okay, yeah. Yeah, in the back, that door next to the shell thingy. Right there, yeah. That cabinet right there. Okay? Top right. There you go. Alright. Next step. Everyone. Multiply. So you write multiply. 6 times 4, that's 24. So we get 6x minus 24 plus 9. Do we need to move anything around from here? No. So we go straight to what? Well, in this case, we just combine, since they're already, we don't have to move stuff around and anything like that, so we go combine like terms. If you wrote associative property of addition, that's fine, and then you did an extra step for combine like terms, I'll take that. So this becomes what? 6x minus 15. Piece of cake? Yeah. Okay. How are we doing? Yes? And the last one, 4C. 4C. Draw your 2-column table. And it says, use properties and operations to simplify. And they give us -3, parentheses, 5x minus 4, close parentheses, plus 9x. So let's see if you see what I see. So notice that I left everything blank now. So see if you can do the whole process by yourself. Go. What is the first step? What do I write here?
Okay, I mean -3 times 5x minus 4 plus 9x.
Reason?
Given.
Because that was given in the problem. Okay, thank you. Pass it to someone. Step 2. Marissa, what do I go from there?
Distributive property.
Distributive property. So I distribute this to this and this to this. So I'm going to write it out first. -3 times what? 5x minus -3. Oh, let me change that. -3 times 4 plus 9. What do I do from there? Pass to someone?
Oh, me? Isaac.
Isaac. Multiply. So then we get -15x, -3 times -4, that's, times +4, that's -12. But there's a negative, and that becomes what? +12 plus 4. What do we do from there? Pass it. What is it? Alyssa. No, just look at it. Look at it, look at it. Look at it, look at it. Hold on. No, tomorrow. Combine like terms. Oh, plus 9, my bad. 9x, my bad. So combine like terms, so we can't combine here, so we need to do what? Commutative property first, right? Anyways, you know how to fill these out? So our homework for tonight is on pages 61 and 63. Have a good one, everyone. Enjoy your homework. See you guys tomorrow.